Math. When you need help, you use Minute Math.
Hi, I'm Sean Gannon, and this is Minute Math. And today we're going to learn about radical equations. And we're going to solve each equation and remember to check for extraneous solutions. So, if I was given this equation, the square root of 110 minus n, square root goes over all of it, equals n. Well, I want to eliminate the square root, so I'm going to square both sides. So in squaring both sides, I'm left with 110 minus n equals n squared. Now, I'm going to get everything over to one side and set it equal to 0 so I can factor. So I'm going to add an n to both sides here, and I'm going to subtract a 110 to both sides. And then I imagine there's some zeros there or whatever. So I have 0 left here equals n squared plus n minus 110. Now I think to myself, okay, since there's a ones in our a value, if you didn't know about factoring, but negative 110, what multiplies to be negative 110 but adds to be a 1? So we said what adds to be 1, so it's a little question mark, what adds to be 1 but multiplies to be negative 110. Okay, so what two numbers add to be 1 and multiply to be negative 110? Well, that's going to be a negative 10 and a positive 11. Negative 10 times positive 11 is a negative 110, and they add together to be a positive 1. So, meaning I can factor this one out to be n minus 10 and n plus 11. Okay? Now, what that allows me to do by doing that, by factoring it out, I can set each parenthesis equal to 0 to solve, which becomes pretty easy to do now. We have, well, n minus 10 equals 0 and n plus 11 equals 0. Well, that just means n equals a positive 10 and n equals a negative 11. Okay, so we have our two answers here, 10 and negative 11. But I need to check really if any of them are extraneous. So here's my check. Let's go check this. So I have to plug both into our original equation. So let's do n equals 10 first. I'm going to plug 10 and see if it's a true statement. So I have the square root of 110 minus n equals n. Plug 10 in. Square root 110 minus 10 here. Equals n, equals 10. Is that true? Well, 110 minus 10 is 100. And square root of 100 is 10. So we're good. That's our check here. So far we know that n equals 10 is a true statement. We're good. Let's see if n equals negative 11 is extraneous. So we have n equals negative 11. So we rewrite our equation. 110. 10 minus n equals n. I'm going to plug negative 11 in. So square root of 110 minus negative 11 equals negative 11. Minus a negative is plus a positive. 110 plus 11 is 121. And right here we can see, well, this number is positive, this one's negative, right? Square root of 121 does not equal negative 11, not at all, right? I believe it's positive 11 off the top of my head. A quick calculator I'm drawing a blank really right now, but we'll see. 121 divided by 11 is 11. It is true. I was correct. Just wanted to double check here. But 11 does not equal negative 11. So that is our extraneous solution. That is our extraneous solution. But n equals 10 is our only solution, and n equals negative 11 is not. So our true solution is n equals 10. Negative 11 is our extraneous solution. P equals the square root of 2 minus p. Well, first step is I'm going to square both sides to get rid of that radical. So by squaring both sides here, p squared just comes down, and that equals 2 minus p on the right. Now I'm going to bring everything over to the left and set it equal to 0. So we have p squared. By adding a p, I have a plus p to this side, and I subtract 2 minus 2 equals 0. Okay? Kind of skipping some steps here, so if you need time, you can write it all out, but I'm just subtracting 2 over and adding a p. Okay? Then from here, I need to factor. Okay, I'm factoring this. What two numbers multiply by negative 2 but add to be 1? And that is a negative 1 and a positive 2. What two numbers multiply to be negative 2 but add to be a 1? All right. Now, if you have trouble with factoring, there's other videos to help with you in factoring, but here I'm kind of jumping ahead. So if p minus 1 times p plus 2 equals 0. So now that this is factored, okay, I can set each part equal to 0, so my solutions here, right, are p equals a positive 1 and a negative 2. Those are my two solutions, okay? But I need to check if they are extraneous. So here's my check. I'm going to check this. So to check it, I'm going to start with the first one and say p equals 1. Okay, p equals 1. I'm going to take my original equation, p equals the square root of 2 minus p, and I'm going to plug 1 in for p, for both p's, to see if it comes out to be a true statement. So 1 goes in here, 2 minus 1. Okay, 2 minus 1 is just 1. Fantastic. It's square root of 1, and square root of 1 is just really 1. Great. True statement, so I know p equals 1 is a true solution. Let's check negative 2. So if p is negative 2, does it also come out to be true? So I have p square root of 2 minus p here. I'm going to plug negative 2 for p. So negative 2 equals 2 minus negative 2. Okay. Well, 2 minus a negative 2 minus a negative is a plus a positive. So if negative 2 equals square root of plus a positive, right, 4. Square root of 4 is 2. And does negative 2 equal 2? No, it does not. Since negative 2 does not equal 2, we can say that p equals negative 2 is an extraneous solution. So my only true solution is p equals square root of 30 minus x equals just x. Well, I want to square both sides to get rid of that square root. So I'm going to square both sides here. I'm going to solve this. So I have 30 minus x equals x squared. And I'm going to bring everything over to one side. So I have 0 then equal to x squared plus an x minus 30. And if this is too fast, take your time. And there's other videos that can help you bring that over. But I'm kind of jumping through some steps here. Now I need to factor that. So I'm going to factor this. And I really need to think, well, what two numbers multiply to be negative 30 but add to be 1? And that's going to be a negative 5 and a positive 6. Okay? Negative 5 times 6 is 30, and they add together. Negative 5 plus 6 is a positive 1. Because remember, there's that 1 in front of the x there. So that leaves me with two answers. X equals positive 5 and a negative 6. Right? If we set both parts of these factor it out, both parts equal to 0, and solve, we get x equals 5 and x equals negative 6. So from there, I need to check for my extraneous solutions. Let's check it. So we need to plug it back into our original equation. So let's do the first one, x equals 5. So I take my equation, 30 minus x equals x, and then the square root there. And I'll plug 5 in. So 30 minus 5 equals 5. 30 minus 5 is 25. Fantastic. And the square root of 25 is, in fact, 5. So we're good. Left and right are equal. We know x equals 5 is a true answer. Let's go check negative 6. So I have x equals negative 6 here. Let's go rewrite my equation. 30 minus x equals x. Plug negative 6 in for x. So we have 30 minus a negative 6 equals negative 6 on the right. Minus a negative is plus a positive. So the square root of 36 equals negative 6. Square root of 36 is positive 6, and unfortunately 6, it does not equal a negative 6. And so this is my extraneous solution. Negative 6 is my extraneous solution, meaning that when I solved here, I got an answer, but when I checked, it didn't come back full circle. So it's extraneous. So my only true solution is x equals 5. X equals the square root of 8x. Well, our first step here is I need to square both sides to get rid of that radical. So I square both sides here. And I'm left with x squared equals 8x. From there, I'm going to subtract an 8x of both sides, leaving me with x squared minus 8x equals 0. Remember, that's subtracting over. A lot of people just want to divide it. No, subtract that 8x over. So if x squared minus 8x equals 0, now I need to factor that. And this one's actually pretty easy. All I have to do is pull out an x. So I have x times x minus 8. equals 0. Now I set both parts equal to 0, so I have x equals 0 and a positive 8. So those are my two solutions here. I need to see if both of them, one of them, or none of them are extraneous. So I'm going to plug them back into my original equation. We'll start with 0. So x equals 0. So we have our original equation, x equals the square root of 8x. And let's see if this is true. Let's plug 0 in. 0 times the square root of 8 times 0. 8 times 0 is just 0. Square root of 0. Got to put an equal sign in between them. Equals 0. 0 does equal 0. That's true. Fantastic. 0 is a true solution. Let's try the other one, x equals 8. Let's see if it's extraneous. So I'm going to take my original equation, x equals square root of 8 times x. Let's plug it in, right? Plug it in here. So 8 for x, or 8 times 8. Well, 8 times 8 is 64. Fantastic. Square root of 64 is 8, right? So my left and right are equal, right? They are equal. So what that means is both of these were true solutions. Neither one was extraneous. That could happen. So we have x equals 0 and a positive 8, and those are my two solutions here. X equals the square root of 42 minus x. Okay? Well, in doing so, what I need to do is I'm going to square both sides here. So I'm going to square both sides to eliminate that radical. X squared is on the left equals 42 minus x on the right. Bringing everything over to the left-hand side of x squared minus x, plus x, right, because I'm adding x here, minus 42 equal to 0. From there, I need to factor what two numbers multiply to be negative 42, but add to be 1, and that's a negative 6 and a positive 7. So I have x minus 6 and x plus 7 is how you factor that. From there, I know that my two solutions are x equals positive 6 and negative 7. We set both of those parentheses equal to 0 to solve. So I have 6 and negative 7. I need to check for extraneous solutions. So let's go for it. Let's do x equals 6 first. This is my check. So, oh man, I'm writing off my 6 there. Can't do that. And it looks all right. So we have x equals the square root of 42 minus x. I'm going to plug 6 in for both my x's. Man, I can't write any of these numbers here. 42 minus 6, well 42 minus 6 is 36, so I have 6 equals the square root of 36. Looking promising, square root of 36 is 6. Oh, a lot of 6's here. So 6 does equal 6, that is a true statement, fantastic. X equals 6 is a real solution. Let's go try x equals negative 7. So x equals negative 7 here. So x equals square root of 42 minus x. Let's plug negative 7 in. So negative 7 goes in. I have 42 minus a negative 7. Well, 42 minus a negative 7 is like adding a positive 7, right? Positive 7. So that ends up being negative 7 equals a square root of 49. Square root of 49 kind of looks promising, but not really, because we have negative 7 equals a positive 7. That is not a true solution. That is extraneous. And so our only real answer here is x equals positive 6. Of 12 minus r equals r. Well, if I square both sides, I can eliminate the radical, giving me 12 minus r equals r squared. And then from there, right, I have to bring everything over to one side. So 0 equals r squared, right? R squared, oh my goodness, my r's are messing up there, plus r minus 12. So I need to factor that. So I got to think, what two numbers multiply to be negative 12, but add to be a positive 1? Those two numbers are negative 3, plus a positive 4. I got ahead of myself, sorry. Final answers, right, when we set both of them equal to 0, we have r equals a positive 3 and a negative 4. Okay? So when we factor that, we have r minus 3 times r plus 4. Then we set them both equal to 0. We have 3 and negative 4. So we have two solutions. We need to check both of them. So let's do our check here. My E's look like C's. So we have square root of 12 minus r equals r. Let's go plug in. Let's do first one, r equals 3 here. So plug in 3 for r. So square root 12 minus 3 equals 3. Is that true? Well, 12 minus 3 is 9. So square root of 9 equals 3, and square root of 9 is 3. So 3 does equal 3, and we're good. 3 works. So let's go try -4. So x equals -4 here. Well, let's plug it back into our original equation. Let's write it out. 12 minus r equals r. Let's plug -4 in. So 12 minus -4 equals a -4. Plus and minus and negative is like plus a positive. So we have, well, 12 plus 4 is 16. -4. Fantastic. Great. Square root of 16 is a positive 4. Almost there, but no cigar. They're not equal. Positive 4 and -4, not equal. So that's an extraneous solution. -4, when x is -4, that's an extraneous solution. So the only true solution here is r equals, not x equals. Oh my goodness, I can't believe I did that. It's an r. It doesn't matter, you'll forgive me. So r equals 3, and there we go. That's our true solution. The square root of 4n equals n. Well, to solve that, I'm going to square both sides, right? Eliminate that square root. And in doing so, I'm left with 4n equals n squared. Let's bring everything over to one side. So we have 0 equals n squared minus 4n. Remember, that's subtracting a 4n to both sides. Be careful. If you're not seeing that, pause for a second, think about it. That's me subtracting a 4n, not dividing, right? We're subtracting. If you need the help, imagine there's like a +0 over there, okay? So let's factor this. Well, that factors to be n times n minus 4. And so my two solutions here that work are n equals 0 and a positive 4. So I need to check both those answers to see if they're real or extraneous. So let's go to our check here. What's the first one with n equals 0? My equation, 4n equals n. Let's plug 0 in. Looks like an h, but 0 in for n. So I have 4 times 0 here equals 0. 4 times 0 is 0. Fantastic. 0 does, in fact, equal 0, right? Square root of 0 is 0. Good. So 0 is a true solution. Fantastic. Not extraneous. But we got another one to check. So n equals 4. We can't forget it. So the square root of 4n, right, equals n. I don't need that big of a square root, but it's all good here. So square root of 4n equals n. From there, I need to plug 4 in. So I have 4 times 4 equals n. 4, oh my goodness, it's getting late. This is late at night, I'm recording this. Okay, 4 times 4 is 16, so we have square root of 16 equals 4, and square root of 16 is in fact 4. Fantastic. So 4 does equal 4. So wait a minute, we have two solutions here, right? Both are true, none are extraneous. So my two solutions are 0 equals 4, or n equals 0 and n equals 4. Not 0 equals 4, that's stupid. Square root of 5v equals v. That's a weird looking v. All right. Anyway, that's a v right there. I'm going to square both sides. Squaring both sides gets rid of that radical. 5, that's a little better, v, equals v squared. Okay, let's bring the 5v over with the v squared. We're subtracting it. So 0 equals v squared minus 5v. Okay, now we need a factor. Let's pull a v out. So 0 equals v times v minus 5. Right there. Great, looking good. And so now I need to set both parts here equal to 0. My two answers are v equals 0 and a positive 5. So I need to check. I need to check that to see if I have an extraneous solution. So let's go check. And again, these e's look like c's. Sorry. So let's go check first one. B equals 0. So we have square root of 5b equals b. Okay. So square root of 5b equals v. I'm going to plug 0 in it. So I have 5 times 0 equals 0. 5 times 0 is just 0, folks. And square root of 0 again is 0 equals 0. Left and right hand side are equal. True. Fantastic. B equals 0 is a true solution. Not extraneous, but we still have another problem here. So we have b equals 5. Let's check it out. Square root of 5b equals b. Let's plug a 5 into that bad boy here. So 5 times 5 equals 5. Let's just the 5's club. 5 times 5 is 25, and the square root, and square root of 25, pretty easy here. Square root of 25 is just 5. and 5 does equal 5. And so this is also a true statement, meaning I have two solutions here, none are extraneous, and they are, folks, 0 and 5. R equals the square root of, I'm writing sideways, 10R. I'll fix it in the next part here. To get rid of that square root, again, like always, I'm squaring both sides here. So I'm squaring both sides. Boom. I have R squared equals 10R. Got rid of that square root. Let's bring the 10R over. R squared minus 10R equals 0. Then we'll factor it. Let's just pull out that R. So R times R minus 10 equals 0. We set both parts equal to 0 here, and so we have R equals 0 and positive 10 are our two solutions. Well, two solutions so far. We got to check it, right? Check for our extraneous solutions. See if any of them are extraneous, okay? So let's check here. Again, those E's throw me off. All right, check. So let's rewrite our equation. R equals 10R, and that's a little more level there. We're going to plug R equals 0 in. 6, that's a 0. Okay, 0 equals 10 times 0. What's 10 times 0? Easy. 0 times anything is 0. So we have 0 equals 0 here, or square root of 0. Square root of 0, 0. So left and right hand side are equal. Looking good, right? Means 0's a true solution. But we have two solutions we came up with, so we got to check both of them. Let's not skip on our work here. So we have R equals 10 here. Don't be lazy. R equals square root of 10 times R. Let's plug 10 in. 10 equals square root of 10 times 10. 10 times 10, 100. Fantastic. Looking good. Square root of 100 though, just 10. So we have 10 equals 10. Hey, that looks good, right? That looks great. They're both equal. So we have, R equals 10 works too. So we have two solutions, 0 and 10. None are extraneous. We don't care about that one and this one here. Both are true. So we have R equals 0 and 10. Equation M equals the square root of 56. Don't know why I made that big noise, but hey, it's all good. Equals square root of 56 minus M. I'm going to square both sides. Let's get rid of that radical. I don't like it. Doesn't need to be there. M squared equals 56 minus M. Now I got to bring everything over. I'm going to add the M to both sides, subtract the 56 to both sides, and I'm left with M squared plus M minus 56 equals 0. Let's factor that bad boy. What multiplies to be negative 56 but add to be M? I'm thinking some 7s and some 8s maybe. So we have M's here, M, looking at it, oh, positive 8, negative 7. Okay, so we have M equals positive 8 and negative 7. So from there, I know I can set it as M equals positive 7 and negative 8, flipping it around there. And what we need to do is you set both parts equal to 0 and solve. When it's kind of this simple, it's just the opposite of what's there written, positive 7, negative 8. But it's all good. This video is not about factoring. So we have M equals 7 minus negative 8, or sorry, 7 and negative 8. Let's check them. Because we gotta see if any of these bad boys are extraneous. Right? I don't like extraneous ones. So we have, let's do M equals 7 first. So M equals the square root of 56 minus M. Let's go plug that 7 in for both of our M's. 7 equals 56 minus 7. 56 minus 7, what does that come out to be? That's 49. That's 49, folks. Right? Not the 49ers, but the 49 right here. Square root of 49 is just 7. Oh, yes! Left and right hand side are equal. Fantastic. 7 is a true answer, not extraneous. So we have two answers here. We got to check both of those bad boys. M equals negative 8. Let's rewrite our equation. 56 minus M. If I can rewrite the equation, you can too. Homework or whatever you're doing here. Negative 8, let's plug it in. Negative 8 equals square root of 56 minus a negative 8. What does that come out to be? Well, minus and negative is like plus and positive, right? Plus positive. So negative 8 equals square root of 56 plus 8 is 64. 64. So square root of 64, oh fantastic, my hopes are high here. Square root of 64 is 8, oh wait, no. negative 8 and positive 8, not equal. Be careful, folks. Be careful, okay? A lot of people here will all of a sudden be like, oh, let's just get rid of the negative and it's equal. No, it's okay. They're not equal, right? Negative 8 and positive 8 aren't the same. That is our extraneous solution. Negative 8, extraneous. Extraneous. So our only true solution here is m equals 7, and there we are. Okay? It's the only one we checked it worked out. Don't need that negative 8. He's not a good friend. Here, b equals the square root of negative 4 plus 4b. All right, got to square both sides. Get rid of that square root. Squaring both sides. Doing it. On it. Done. We have negative 4 here plus 4b on the right-hand side and b squared on the left. Radicals done. Bring everything over to left-hand side together. So b squared, have a quadratic, minus 4b plus a 4 equals 0. Now I got to factor that bad boy. b and b, what two numbers multiply to be positive 4 but add to be negative 2? Kind of tricky, but just negative 2 and negative 2. So equals are 0. So we set both of them equal to 0, and we have b equals 2 and 2. We have 2, right? Well, only need to write 1. We don't need to write that it's 2, right? b, 2, 2. So when I check here, I'm going to check one of them, right? It'd be very foolish to check both, please. I mean, I've seen students do it. Fine, whatever, float their boat. I guess, it works, but, I mean, I've seen it before where students do it and they somehow plug 2 both times, check it twice, and got 1 true, 1 not. I don't know. But either way, you only need to do it once. b equals square root of negative 4 plus 4b. Let's go plug a 2 in. 2 in for b. We have negative 4 plus 4 times 2 here. Simplify. 2 equals negative 4 plus 4 times 2 is 8. Negative 4 plus 8 is positive 4. 2 equals square root of 4. Square root of 4 is 2. Left and right hand side are equal. Okay, fantastic, great. 2 is a true solution. So I only need to write it once. b equals 2. Okay, 2 is my only solution here. Your teacher, will they mark you off if you write it twice? Probably not. I never really did. Yeah, you only need to write it once. So b equals 2 is our only true solution. There's no extraneous solutions here. r equals the square root of 8r. Okay, I'm going to square both sides here. Let's square it. Let's do that. Square both sides. r squared equals, got rid of the square root, 8r. Okay? From there, I need to subtract an 8r on both sides. So we have r squared minus 8r equals 0. Okay? And make sure you're subtracting 8r, don't divide. Doesn't really eliminate anything here. Okay? Subtract an 8r to both sides. Factor that out, pull out an r times r minus 8 equals 0. Set both of them equal to 0. And get r equals 0 and a positive 8. Okay? So now I need to check both of these. Let's check them. So I'm checking them. Let's check r equals 0 first. Let's plug it back into our original equation. 0 in for r. I always love it when it's 0. It makes it so much easier once you know what you're doing. Right? 8 times 0 is just 0, so 0 equals 0. Square root of 0, 0. So 0 equals 0. Fantastic, great, looking good. R equals 0. It's not extraneous. It worked out. We checked it. It's good. Okay? I give it my seal of approval. So I have r equals 8 as the other one. I got to check that too. So we have r equals 8. So let's rewrite the equation. R equals 8r. R equals square root of 8r. Let's plug 8 in. All these 8's everywhere. 8 equals square root of 8 times 8. How many 8's can we have here? So 8 times 8 is 64. So if 8 equals square root of 64, I get confused sometimes. It's okay. Square root of 64 is just 8. So we have 8 equals 8. Left and right hand side are equal. Fantastic. That means both of these are true. No extraneous solutions here, folks. We have r equals 0 and r equals 8. Both are true, both are fantastic, and we're good to go. Square root of negative 16 plus 10a equals a. Well, first step, I need to square both sides. Let's get rid of that radical. Squaring both sides, negative 16 plus 10a equals a squared. Let's bring everything over to the right-hand side, leaving a 0 here equals a squared minus 10a plus 16. Okay, so now we think to ourselves here, what two numbers multiplied to 16 add to be negative 10? And that ends up being, right? Ends up being negative 8 and negative 2, right? Double negatives multiply to be positive, and they add together to be at negative 10. Great. Set both parts equal to 0, so I'm left with our answer here and solving it. A equals 8 and a positive 2. All right, so 8 is 8 and positive 2, so now I need to check both of those. So let's check them. Check for extraneous solutions here. So let's do A equals 8 first. Okay, I have my square root, negative 16 plus 10 times A equals A. Let's plug 8 in for A here. Negative 16 plus 10 times A, or 8 equals 8. 10 times 8 is 80, so we have negative 16 plus 80 equals 8. And what's 80 minus 16? That's going to give us a 64. So we have square root of 64 here equals 8. Square root of 64 is just 8. And so 8 equals 8. Fantastic. That's a true statement, making that A equals 8 true, not extraneous. But we have two parts. Let's check both of them. A equals 2. So I'm going to rewrite our equation. Negative 16 plus 10A equals A. And we're going to plug a 2 in. So we have negative 16 plus 10 times 2 equals 2 here. Okay? Well, 10 times 2 is 20. So we have negative 16 plus 20 equals 2. Negative 16 plus 20 is 4. So we have 4 here equals 2. Square root of 4 is 2. And in this case, my left and right hand side also are equal. So that makes both of these A equals 8 and 2, or 2 and 8. It's a little nicer. Let's make it nice and neat, Sean. Come on, you're better than that. 2 and 8 here. 2 and 8 are true solutions, right? None are extraneous. R equals the square root of negative 1 minus 2r. Okay? So what I'm going to do is I'm going to square both sides, right? Let's get rid of that square root. So we have r squared here equals negative 1 minus 2r. That's 4. I am getting tired. Okay? I'm going to bring everything over to the left-hand side, leaving me with r squared plus 2r plus 1 equals 0. Okay? So now I'm going to try to factor this, right? I'm going to factor that. What two numbers multiply to be a 1 but add to be a 2? Well, that's pretty simple, right? What two numbers multiply to be a 1 and to be 2? That's r plus 1 and r plus 1, right? 1 times 1 is 1. 1 plus 1 is 2. Fantastic. Don't need to write both of them, but we set them both equal to 0. R equals negative 1 and negative 1. Okay? So when we check it here, right, we only have to check one of them. R equals negative 1. Let's check it into our original equation and see if we have an extraneous solution. So we have r equals the square root of negative 1 minus 2 times r. I'm going to plug just one of them in, negative 1 in. So I have negative 1 equals the square root negative 1 minus 2 times a negative 1. Okay? Now be careful here with our negatives. So we have negative 1 equals the square root of, well, negative 1 minus 2 times negative 1 is a negative 2. Okay? Now we have plus a negative, which is plus a positive. So negative 1 equals square root of negative 1 plus 2 is a positive 1. Square root of 1 is a positive 1. Negative 1 equals a positive 1. Fantastic. But except the negative 1 does not equal a positive 1. That's incorrect. Incorrect here. Okay? And so, since it's incorrect, that means that's an extraneous solution, right? So negative 1's extraneous solution. So actually, none of these worked, right? It was written twice, but none of them worked. There's actually, that's not it. We're looking at N. No solution. And that's my answer. There is no solution here. Okay? No real solution. There's extraneous solutions, but no solution. Square root of negative 45 plus 14n equals n. First step, got to square both sides. Let me show that. I'm just getting ahead of myself. The answer would be negative 45 plus 14n equals n squared. Let's bring everything over to the right-hand side, set it equal to 0. 0 equals, I'm going to add a 45 and subtract a 14n to both sides. So we have n squared minus 14n plus 45. Okay? Then we think to ourselves, what two numbers multiply to be 45 but add to be negative 14? That's 9 and 5, but both being negative. So we have 0 equals n minus 5 and n minus 9. 9 times 5 is 45. Negative 9 times negative 9 is also 45, but they also add to be negative 14. So now we can set both of them individually equal to 0, and we get n equals positive 5 and a positive 9. But our work isn't done. We need to check for our extraneous solutions. So we do our check here. Okay? And we start with n equals 5. So we're going to rewrite our equation, square root of negative 45 plus 14n equals n. I'll plug 5 in, square root of negative 45 plus 14 times 5 equals 5. Okay, right there. What's 14 times 5? 5 times 10 is 50. 5 times 4 is 20. So we're looking at 70 here. So we square root of negative 45 plus 70. Negative 45 plus 70 comes out to be, so that's 45, looking at 25. So we're looking at 25 here. And the square root of 25 is 5. Our left and right hand side are equal. Fantastic, right? So that means 5 is a true solution, but we had two bad boys here. We got to check the other one. So we go n equals 9. Let's go rewrite our equation. Negative 45 plus 14n equals n. Plug 9 in for n. Square root of negative 45 plus 14 times 9 equals 9. Okay, what's 14 times 9? Don't know that off the top of my head, so let's do some multiplication here. 14 times 9. 9 times 4 is 36. 6 carries a 3. 9 plus 3. 9 times 1 is 9. Plus 3, looking at 12, so 126. So we have negative 45 plus 126 equals 9. What's 126 minus 45 essentially? 126 minus 45. I have a feeling it's 89, but could be wrong. 81, sorry. 81, not 89. 81, right? 12 minus 4 is 8. 81. I think 89, 81. Alright, so we have the square root here of 81 equals 9, and the square root of 81 is 9. Left and right hand side were both equal. Fantastic, confirming that 9 is a true solution. So we had no extraneous solutions in this case, and so our two answers are 5 and 9. X equals the square root of 1/10 minus x. Okay? Well, first thing, I got to square both sides. Let's get rid of the square root. So I'm squaring here, Left with an x squared equals 1/10 minus x. Then I'm going to bring everything over to the left-hand side. So we have x squared plus an x minus 1/10 equals 0. Subtracting the 1/10 on both sides and adding the x. So now I need to factor that. Well, what two numbers multiply to be negative 1/10 and add to be 1? And we are looking at here a negative 10 and a positive 11. 10 times 11 is 110. Negative 10 times 11 is negative 110, but when we add those two together, we get a positive 1. So our two solutions, when we set each one equal to 0, is x equals positive 10 and a negative 11. So now I need to check these. Check them for extraneous solutions. So let's do our check here. Okay. First one, x equals 10. Well, x equals square root, I rewrite the equation, right, of 1/10 minus x. And then I plug x in, substitute it in, both of the x's. So 1/10 minus 10. 1/10 minus 10 is 100. Square root of 100 is just 10. Left and right hand side are equal. Fantastic, looking good. X equals 10 is a real solution, but I got one more to check. Can't forget him. He's just sitting there. Can't forget him. I'm rewriting my equation here. Fantastic. Then I'm plugging negative 11 in for x. So negative 11 here equals 110 minus negative 11. Subtracting a negative is the same thing as adding a positive. So we have negative 11 equals the square root of 110 plus a positive 11, which is 121. Okay, 121. Square root of 121 is just 11, so we have negative 11 equals 11. Oh, not the same, right? Negative 11 and positive 11 are not the same. That means that negative 11 is an extraneous solution. So my only real solution here is x equals 10. Square root of 9, n equals n. First step, square both sides. Okay, I square both sides here, and I'm left with 9n equals n squared. Let's bring the 9n over and subtract 9n to both sides. So that's 0 equals n squared minus 9n. Now I need to factor that. Just pull out an n here. So 0 equals n times n minus 9. Set both parts equal to 0, and we're left with n equals 0 and a positive 9. Okay? So those are my two solutions, but I have to check for extraneous ones. So I'm going to take n equals 0 first. I'm going to substitute it into my equation here. So square root of 9n equals n. 0 goes in for n. Square root of 9 times 0 equals 0. 9 times 0, just like anything times 0, is 0. So we have square root of 0 equals 0. And the square root of 0 is just 0. Almost redundant, but it's all good. And they're equal, right? Left and right hand side are good, equal. 0 is a true solution. Let's go try 9. So we have n equals 9. I'm going to take my equation here. 9n equals n. Plug 9 in for n. So we have square root of 9 times 9 equals 9 here. 9 times 9 is 81. So the square root of 81 equals 9. Square root of 81 is just 9. 9, in fact, does equal 9. True statement. Making that also a real solution, right? Left and right side are equal. True solution. No extraneous solutions here, so we have n equals 0 and 9, and that, folks, are our two answers. X equals the square root of 4d minus 3x. Okay? Well, I'm going to square both sides here. Get rid of the radical. Leave me with x squared equals 40 minus 3x. Then I'm going to bring everything over to the left-hand side. So we have x squared plus a 3x minus 40 equals 0. Now I need a factor. We have x here, x there. What two numbers multiply to be negative 40 but add to be 3? We're looking at a negative 5 and a positive 8. Right? Negative 5 times positive 8 is negative 40, but when I add those two together, I get positive 3. That, when we both set both these parts equal to 0, we're left with x equals 5 and a negative 8. So we need to check this, right? We're going to check it. We're going to plug it back in to our original equation. Let's go x equals 5 first. So we're left with start with x equals square root of 40 minus 3x. Checking for that extraneous solutions here, plugging 5 in, equals square root of 40 minus 3 times 5. 3 times 5 is 15. So we have square root of 40 minus 15. 40 minus 15 comes out to be 25. So we have 5 equals square root of 25. And the square root of 25 is just 5. So we have 5 equals 5. Fantastic. Left and right hand side are equal, making 5 a true solution. Let's try the next one, negative 8. We have two problems here, or two answers, but we got to check both of them, folks. We can't leave it alone. X equals square root of 40, and please take your time, rewrite the equation. Let's not skip any steps here. Okay, negative 8 goes in for x. Negative 8 equals 40 minus 3 times a negative 8. Okay, 3 times negative 8 is a negative 24, so we have 40 minus a negative 24. Subtracting negative, same thing as adding a positive. So we have 40 plus a positive 24. 40 plus 24 is 64, so we have negative 8 equals the square root of 64. Square root of 64 comes out to be a positive 8. Positive 8 here. They're not the same, right? Negative 8 and positive 8 are not the same. So this negative 8 here is not a real solution. It's an extraneous solution. So my only true answer is x equals 5. Square root of 90 minus n equals just n. Okay? Square root of 90 minus n equals n. First thing, I need to square both sides. Get rid of that square root. Square both sides here. So we have 90 minus n equals n squared. Then from there, what I need to do is bring everything over to one side. So I'm left with 0 equals n squared plus n minus 90. Okay? Plus n minus 90. So I subtracted a 90 to both sides. I added an n to both sides. Now I need to factor that. All right. What two numbers multiply to be negative 90 but add to be 1? What's in front of the n? And that's a negative 9 and a positive 10. Right? Negative 9 times 10 is negative 90. Add them together, get positive 1. So with that, I know my two solutions because I set both of these parentheses in equal to 0, right? And solve. I have n equals positive 9 and negative 10. So now I need to check my work. So I'm checking here, not just my work, but for really extraneous solutions here. I'm going to take my n equals 9, first one, and let's plug it into the original equation. So we have 90 minus n equals n. 9 goes in for n, so we have square root of 90 minus 9 equals 9. 9s and n's, I always get those mixing up here. So 90 minus 9 is 81 equals 9. Square root of 81 is just 9. So 80 square root of 81 is 9. 9 equals 9. Fantastic. Left and right hand side are equal. So we're making this a true statement. We're good, right? Real answer. We got it. It's not extraneous. But we have two numbers. Let's check both of them. Negative 10. So the square root of 9 minus n equals n. 90 minus n equals n. Plug it in. Negative 10 goes in, so we have 90 minus a negative 10 equals negative 10. Subtracting a negative, same thing as adding a positive, so we're left with 100 here equals negative 10. Square root of 100 equals negative 10. Square root of 100 is just 10. Oh, 10 and negative 10 are not equal, right? One's negative, one's positive, so negative 10 is an extraneous solution that we have written up there. So our only true answer here is n equals 9. X equals the square root of negative 70 plus 17x. Okay? Well, first thing I need to square both sides. Leaving me with x squared equals negative 70 plus 17x. From there, I brought everything over to the left-hand side. X squared subtracted 17x plus 70 equals 0. Okay? Now from that, we need to factor. Right? I subtracted a 17x and I added a 7, just so you can see that. Factor this. What two numbers multiply to be 70 but add to be negative 17? And that's a negative 7, negative 10, right? Negative 7 times negative 10 is a positive 70, but they add together to be negative 17. When I simplify, I set both parts equal to 0. I'm left with x equals 7 and 10. Fantastic, looking good. And so from there I want to check this. I have, well, x equals 7 here, okay? Check x equals 7, so we have x equals the square root of negative 70 plus 17x, okay? We're going to plug 7 in for x to see if that's a true solution here. So we plug 7 in. Negative 70 plus 17 times 7. What's 17 times 7? I probably fit it right here. Okay, 17 times 7. 7 times 7 is 49. 7 times 1 is 7 plus 4 is 11. So we have 119. So we have 7 equals square root of negative 70 plus 119. Looking at what, 30, 49 apart? Yeah, so negative 70 plus 119 is 49 units apart. So we have 7 equals a 49. All right, 119 minus 70, same thing, is 49. Square root of 49 is just 7, so 7 equals 7. Left and right hand side are equal. Fantastic, looking good. 7 is a true answer, but we have 2. We got to check both. So x equals 10 here. Rewrite my original equation. Don't skip that. Negative 70 plus 17x. Plug 10 in. 10 equals square root of negative 70 plus 17 times 10. Parentheses, it's getting messy. Times 10 there. That's a 10, in case you're wondering. 17 times 10 is 170, so 10 equals square root of negative 70 plus 170. Negative 70 plus 70 is just 100, so we have 10 equals square root of 100 here. Square root of 100 is just 10, so 10 equals 10. Left and right hand side are both equal, no extraneous solutions here, and so my 2 solutions are, in fact, they're real, totally real, and they're 7 and 10. Equation, the square root of 4n plus 8 equals n plus 3. Okay? Square both sides, let's eliminate that radical. Leave me with 4n plus 8 equals n plus 3 times n plus 3 squared, right, is n plus 3 times n plus 3, so let's write that out. N plus 3, n plus 3. Now I need to distribute that n plus 3 when we multiply, right? So I'm going to 4n plus 8. You might have heard it as FOIL in school, right? First, outer, inner, last. N times n is n squared. You get better at this the more you practice it. N times 3 plus n, 3 times n is 6n. And then 3 times 3 is 9, okay? So from there, I'm going to subtract a 4n's, bring everything over to the right-hand side, and subtract an 8. Leaving me with 0 equals n squared. 6n minus 4n, which is 2n. 9 minus 8 is plus 1. So we think about what 2 numbers multiply to be 1 and add to be 0. We factor this out. Well, that's going to be a positive 1 and positive 1, right? 1 times 1 is 1. 1 plus 1 is 2. So when we solve this, set both parts equal to 0, we're left with n equals a negative 1 and a negative 1 here. Okay? So let's check. We check our work here. We're checking, well, really for extraneous solutions, but sometimes we need to check our work. Square root of, what's the first one? Negative 1. And really, I only have to do one check, right? Because negative 1 and negative 1 is redundant to do it twice. So we have 4n plus 8 here equals n plus 3. Okay? Negative 1 goes in for n, so I have 4 times a negative 1 plus 8 equals negative 1 plus 3. 4 times negative 1 is a negative 4, so I have negative 4 plus 8 here equals negative 1 plus 3, which is 2. Negative 4 plus 8 is a positive 4. Square root of 4 equals 2. Square root of 4 is 2. 2 equals 2. Fantastic. Looking good. Okay, looking good there. The left and right hand side were both equal, leaving me with the knowledge that there were no extraneous solutions, and n equals negative 1. Only need to write it once here, is my only real solution. Negative n plus the square root of 6n plus 19 equal to 2. Okay? Well, to solve this, I'm going to bring the n over to the right. So I'm going to add an n to both sides, leaving me with the square root of 6n plus 19 equals n plus 2. Now I can square both sides to get rid of the radical. Make sure when I square, I also square the n plus 2. Leaving me with 6n plus 19 here equals n plus 2 times n plus 2. Comes out to be n squared plus 4n plus 4. Okay? Now I'm going to subtract everything over. Subtract the 6n to both sides, and subtract 19 to both sides, leaving me with 0 equals n squared minus 2n minus 15. So now we think, when we factor here, what 2 numbers multiply to be negative 15, but add to be negative 2. Excuse me, and that's a negative 5 and a positive 3. And so my 2 solutions here are positive 5 and negative 3. And now I need to check both of those, okay? So I set both parentheses equal to 0, and got 5 and negative 3. So we do our check here. So we're left with, or checking here, n equals 5. So negative n equals square root, but the square root is plus. Getting ahead of myself here. Plus the square root of 6n plus 19 equals 2. Keep everything on their own side here. That 5 can be a little neater. Let's plug 5 in. Negative 5 plus square root of 6 times 5 plus 19 equals 2. Okay? 6 times 5 is 30. So we have negative 5 plus square root of 30 plus 19 equals 2. 30 plus 19 is 49. So we have negative 5 plus the square root of 49 equals 2. Square root of 49 is 7. So negative 5. Stop speaking different numbers that I'm writing. Negative 5 plus 7 equals 2. Negative 5 plus 7 is 2, so 2 equals 2. Left and right are equal. Fantastic. 5 is a true solution. Looking good. We have two solutions. We got to check the other ones. Go n equals negative 3 here. Rewrite my equation. Negative n plus square root of 6n plus 19 equals 2. Let's plug negative 3 in. So negative 3 gets plugged in there, right? Plus square root of 6 times negative 3 plus 19 equals 2. Well, negative 3 is just a positive 3. Plus the square root of 6 times negative 3 is negative 18 plus 19 equals 2. Negative 18 plus 19, well, that's just 1, right? So we have 3 plus the square root of 1 equals 2. Well, square root of 1 is just 1, so we're left with 3 plus 1 equals 2. And 3 plus 1, well, 3 plus 1 is 4. Does 4 equal 2? No. Not true solution. So what that means that this is an extraneous solution, that negative 3 is our extraneous solution, and so our only real solution is n equals 5. 4 plus the square root of negative 3m plus 10 equals n. Well, first thing is I need to bring that 4 over to the right to isolate the radical. So we have the square root of negative 3m plus 10 here. Subtract the 4 equals m minus 4. Then from there, I need to square both sides. Squaring both sides eliminates that radical, leaving me with 3m plus 10 on the left equals m minus 4 squared. Now I'm going to multiply that out, right? M, so that comes out to be m squared minus 8m plus 16. Because remember, m minus 4 squared is m minus 4 times m minus 4, and then I would distribute that, right? It'd be FOIL. So sometimes you can do that in your head. If not, pause it, take your time right now, see if you can get there. From there, I'm going to bring over the 3m and the 10, so I'm going to add a 3m to both sides, subtract the 10, and that's going to leave me here with m squared, right? Adding 3m to the 8m, negative 8m, is a negative 5m, and I've subtracted 10 to both sides, and it gives me a plus 6. From there, I need to factor. All right, what two numbers multiply to be 6 and add to be negative 5? And that's going to be, well, what do we got here? Add to be 6, but multiply to be 6, add to be negative 5, and that's a negative 2 and a negative 3. Okay, so my two solutions here, right? Because negative 2 times negative 3 is a positive 6, and we add them, we get negative 5. So my two solutions here, if I set each part equal to 0, is m equals 2 and 3. So what we need to do is check that. Check that to see if we have any extraneous solutions. So I'm going to take m equals 2 first, and I'm going to plug it back into my original equation. 4 plus the square root of negative 3m plus 10 equals m. I'm going to plug 2 in for m. So we have 4 plus the square root of negative 3 times 2 plus 10 equals m, or equals 2. All right, we're plugging 2 into both m's. Don't make that mistake. Negative 3 times 2 is 6. We have 4 plus square root of negative 6 plus 10 equals 2. These two together combined, negative 6 plus 10 is positive 4. So we have 4 plus square root of 4 equals 2. Then square root of 4 is 2. So 4 plus 6 equals 2. Gotta have myself. Square root of 4 is 2. All right, and 4 plus 2 is 6. I'm getting ahead of myself here. And does 6 equal 2? No, it does not. That means 2 is an extraneous solution, right? So it doesn't work, okay? So let's try 3. Let's see if 3 is. So m equals 3. Let's go check that. So we rewrite our equation. Square root of negative 3m plus 10 equals m. Let's plug 3 in for both m's. 4 plus square root of negative 3 times 3 plus 10 equals 3. Negative 3 times 3 is 9. Negative 9, actually. 4 plus square root of negative 9 plus 10 equals 3. Negative 9 plus 10 is 1, so we had 4 plus square root of 1 equals 3. Square root of 1, just a 1. 4 plus 1 equals 3, and 4 plus 1 is 5. equals 3. Again, they're not equal. Left and right are not equal. So both of these are extraneous solutions, right? Don't work, and so we actually have no solution here. There is no solution. Neither one works, and so this equation actually has no solution. X minus 5 equals the square root of x plus 1. Okay? Well, square root's already isolated, so I'm going to square both sides to eliminate that square root. Square both sides here. By squaring both sides, on the left-hand side, I need to multiply that out. That's x minus 5 times x minus 5. That comes out to be x squared minus 10x plus 25 equals x plus 1, which is left here. Let's bring everything over to the left-hand side, subtract an x of both parts. So negative 10x minus x is negative 11x. And then subtract a 1 minus 24 equals 0. Now I need to factor this. What two numbers multiply to be negative 24 but add to be negative 11? And what I'm thinking here, is, okay, what two numbers multiply to be negative 24, okay, but add to be negative 11, and, positive 24, I'm sorry, it's positive, good. I was trying to think that one through. Positive 24, right? 25 minus 1 is a positive 24. We all make mistakes, it's all good. So we have x here, x equals 0. Positive 24, negative 11, I'm thinking minus 3 and minus 8, right? Negative 3 times negative 8 is a positive 24. They add together to be a negative 11. Fantastic. So our two solutions here are 3 and 8. So we need to check both of them here. So here's my check. I'm going to check here. And we have x equals 3 first. So let's rewrite our equation. X minus 5 equals square root of x plus 1. Let's go plug 3 in for both x's. 3 minus 5 here equals square root of 3 plus 1. 3 plus 1 is 4. So we square root of 4 over there. 3 minus 5 is negative 2. Square root of 4 is just 2. So negative 2 equals positive 2. That's not correct, right? They're not equal. So 3 is actually what we call extraneous solution, right? It worked here when we solved, but when we checked it, it didn't come back full circle. Let's check the other one. X equals 8. So we're given x minus 5 equals square root of x plus 1. Let's plug 8 in for both x's. 8 minus 5 equals square root of 8 plus 1. 8 plus 1 is 9. So square root of 9 there. 8 minus 5 is 3. Square root of 9 is 3. Do the left and right hand sides equal? Yes, they do. Fantastic. Making x equals 8 our only solution, right? The other one was extraneous. N minus 7 equals the square root of 3n minus 21. Okay? Well, first thing I need to do is I need to square both sides to eliminate that radical. So I'm going to square both sides here, leaving me with, well, on the right side, 3n minus 21. But on the left side, if we need it, we'll do that step here. N minus 7 squared is really just n minus 7 times n minus 7, if you can see that. Okay? Now, when I distribute that out, that becomes n squared minus 14n plus a 49 equals 3n minus 21. Okay? N times n is n squared. N times negative 7 is a negative 7. Negative 7 times n is a negative 7. Added together gets you the negative 14n. And negative 7 times negative 7 is positive 49. Let's bring these over here. Subtract a 3n to both sides. So it's like term. Add a 21 to both sides. Leaving me with n squared minus 17n plus 70 equals 0. Now I need to think what two numbers multiply to be 70 but add to be negative 17. Should be pretty simple, right? Can you think about it while I'm writing here? Take your time, pause, see if you can do it. Okay? I'm thinking negative 10 and a negative 7. Right? Negative 10 times negative 7 is a positive 70. Negative 10 plus negative 7 is a negative 17. So now our two solutions here, when we set both of them equal to 0, is 10 and 7. Okay? So let's go check these two. Let's check. So x equals, let's do the first one, 10 here. So rewrite my first equation, n minus 7 equals square root of 3n minus 21. Okay? Let's plug 10 in for n, so 10 minus 7 equals 3 times 10 minus 21. Well, 10 minus 7 is 3. 3 times 10 is 30, minus 21. 30 minus 21 is 9. Bring down the 3. Square root of 9 is just 3. And this is great. Left and right hand side are equal. 10 is a real solution. It's not extraneous. But let's try the other one. We have x equals 7 is the other one we need to check. N minus 7 equals the square root of 3n minus 21. From there, I'm going to plug 7 in for my n value. So 7 minus 7 equals square root of 3 times 7 minus 21. 7 minus 7 is 0. 3 times 7 is 21, and we bring down the minus 21. 21 minus 21 is 0. And the square root of 0 is just 0. So in this case, my left and right hand side are also both equal to each other, making 10 and 7 both real answers, right? There's no extraneous solutions. So when I rewrite this, I'm going to write at least to greatest, 7 and 10. It's a little nicer and neater. So our two answers here are n equals 7 and n equals 10. B minus 6 equals the square root of 18 minus 3b. Okay? First thing is I need to square both sides, eliminate that square root. So square both sides here. Leaving me will, if I multiply that out, that's b minus 6 times b minus 6. Gives me b squared minus 12b plus 36 equals 18 minus 3b. Okay? From there, let's bring over the 18, bring over the 3b. So I subtract 18 from 36 and add a 3b. So we have b squared. Negative 12b plus a 3b when I bring it over here is a negative 9b. Plus 36 minus 18 is a positive 12. Gives me, instead of equal to 0. Now I need to factor this. What two numbers multiply to be 12 that add to be negative 9? And I'm thinking of, well, you tell me, what are you thinking of? Factor this out. What are you thinking of here? Huh? Multiplies to be 12, adds to be negative 9. Pause it. If you don't have it yet, think about it. Don't just watch my answer. See if you can do it. Wait. Okay. Minus 6 and minus 3. Those are the two numbers I was thinking. Negative 6 times negative 3 is a positive 12. And if I add them together, they become a negative 9. Okay? So I set both of them equal to 0, and I get b equals 6 and a positive 6 and positive 3. So those are the two I need to check now. Check. Check it up. So let's do the first one, b equals 6. So we have b minus 6 equals the square root of 18 minus 3b. Okay? Let's plug 6 in for b. 6 minus 6 equals, well, 18 minus 3 times 6. And for that b, 6 minus 6 is 0. Fantastic. 18 here. What's 3 times 6? 18. Uh-oh. I'm seeing something. 0 equals square root of 18 minus 18 is 0. Square root of 0 is just 0, so 0 equals 0. Left and right hand side are equal. 6 is a real solution. But hold your horses here. We gotta check 3. Okay? So let's plug 3 into our original equation. B minus 6 equals, and my b's and 6's look alike, I know. Equals square root of 18 minus 3b. 3 goes in for b, so I have 3 minus 6 equals 18 minus 3 times 3. Well, 3 minus 6 is negative 3. 18 order of operations here. 3 times 3 is 9. So 18 minus 9. Negative 3 equals the square root. 18 minus 9 is just positive 9, right? Square root of positive 9 is positive 3. But does negative 3 equal positive 3? I don't think so. Hopefully you didn't either. So 3 is an extraneous solution. So my only true real solution is the first one we had written down was b equals 6. Negative 3 plus square root of m plus 59 equals m. Okay? Well, first thing, as I bring the negative 3 over to the right to isolate the square root, so I'm left with the square root of m plus 59 equals m plus 3. Now that the square root's isolated, I'm going to square both sides. What that does is eliminate the square root, leaving me with m plus 59 on the left, and then m plus 3 times m plus 3 comes out to be m squared plus 6m plus 9. Okay? Now we're going to subtract both sides by m and subtract both sides by 59. Leave me with m squared. 6m minus 1m is plus a 5m. And I subtracted 59 to both sides, and we get a minus 50 here, right? 9 minus 59 would be negative 50, right? So now I need to factor this out. Well, what two numbers multiply to be negative 50 but add to be positive 5? Thinking about it? I'm thinking about it. I'm thinking about a negative 5 and a positive 10. Negative 5 times positive 10 is a negative 50, but negative 5 plus positive 10 is a positive 5. Got it. So we set both of them equal to 0, and we get m equals 5 and a negative 10. So now I need to check both of them for extraneous solutions here. Check both of them. So the first one, m equals 5. Let's do that first. We plug into our original equation, negative 3 plus the square root of 5 plus 59. Whoops, let's do m. Not substituting yet. Getting ahead of myself. That's the next step. M plus 59 equals m. Now I'm going to substitute 5 in for m. Negative 3 plus square root of 5 plus 59 equals 5. Okay. From there, simplify. Negative 3 plus square root of 59 plus 5 is 64. The 5 squared root of 64 is just 8. So we're left with negative 3 plus 8 equals 5. Negative 3 plus 8 is a positive 5. So 5 does equal 5. Fantastic. Makes 5 a true solution. It's not extraneous. But let's try negative 10. So we have m equals negative 10. Original equation. Negative 3 plus square root of m, not 5, plus 59 equals m. Plug negative 10 in for m. So we have negative 3 plus the square root of negative 10 plus 59 equals m. Negative 10 plus 59 is a positive 49. So negative 3 plus square root of 49 equals m. Square root of 49 is just 7. So I have negative 3 plus 7 equals m. And why I didn't plug in m here, or negative 10 in. What am I doing? Forgetting that? Can't forget that step. Ignore what I did earlier. Put a negative 10 in. Can't believe I did that. Negative 3 plus 7 is a positive 4. And does positive 4 equal negative 10? No, it does not. It does not. They're not true. So that means negative 10, an extraneous solution. So our only true solution is m equals 5. Square root of 7, that's an a, 7a minus 54 equals, minus an a, I get ahead of myself too much. Minus an a equals a negative 6. That's it. I made it sound like there's something more, but there's not. I'm going to add an a to both sides, leave me with the square root of 7a minus 54 equals positive a, I'm going to put the a first, plus an a to both sides, minus 6. Then I'm going to square both sides and eliminate that square root. That gives me 7a minus, that's an a, not a 9, 7a minus 54 equals a squared minus 12a plus 36. That's what happens, what a minus 6 all squared is. It's a minus 6 times a minus 6, and you got to distribute. Or FOIL, you might have heard this word, FOIL. Now we're bringing everything over. I'm going to subtract a 7a to both sides and add a 54. So subtract a 7a and add a 54. Leaving me with, well, here, 0 equals a squared. Negative 12a minus 7a is negative 19a. And then 36 plus 54 is 90. So I have a squared minus 19a plus 90 equals 0. So I think, okay, what two numbers multiply to be 90 but add to be negative 19? Take a moment, take a moment, take a moment. Think about it. Tick tock, tick tock, tick tock. Negative 9 and negative 10. Okay? Negative 9 times negative 10 is a positive 90, but they add to be negative 19. When I set both of them equal to 0, I'm left with a equals 9 and a equals 10. Okay? So those are my two answers, but now I need to check for my extraneous solution. So I'm going to do my check here. And I'm going to take both of them and plug them in individually into the equation. So first one, a equals 9. My a's didn't look like 9s, but they're not today. So 7a minus 54 minus an a on the outside. Well, in this case, a will be 9, so it kind of works out, I guess. I'm not giving myself enough room here. Minus 6. Okay? And I didn't say that much. Plug 9 in for a. So now I'm left with 7 times 9 minus 54 minus a 9 equals a negative 6. Okay? Excuse me. So what's 7 times 9? Well, 7 times 9. Have you done the finger tricks? I don't know. I feel like putting that in here. So 7 times 9, you go 1, 2, 3, 4, 5, 6, 7. That comes out to be 63. Right? 6 here left, 3 there. I don't know. Just a trick case you want it. All right, 63 minus 54 minus 9 equals negative 6. Okay? Okay? Well, plugging that in here. Yeah. So 63 minus 54 is a 9, right? 63 minus 54 is a 9, so the square root of 9 minus 9 equals negative 6. Square root of 9 is 3. So 3 minus 9 is a negative 6. And does negative 6 equal negative 6? True. Fantastic. 9 is a real solution. Now I have to do the same check here, and hopefully I have enough room, of a equals 10. So let's put a little wall here to separate them, so it's still not as close. So square root of 7a, take my time here, minus 54, minus a equals negative 6. Okay? So I got to plug 10 in for a, so square root of 7 times 10 minus 54, minus a outside this minus 10 outside the square root equals a negative 6. So imply 7 times 10 is 70, so I square root of 70 minus 54 minus 10 equals negative 6. 70 minus 54 is a 16, right? Yeah, 16. Minus 10 equals negative 6. Square root of 16 is 4, so I have 4 minus 10 equals negative 6. 4 minus 10 is negative 6. And negative 6 does in fact equal a negative 6. My left and right hand side are equal, so my two solutions are both of them that we found, 9 and 10.
Math, minute math. When you need help, you use minute math. Minute math, minute math. When you need help, you use minute math. MinuteMathTutor.com.